right, so linear inequalities, we are now going to have two variables. What you're going to do is the first thing that you're always going to do, because we're going to have to graph on an x and y plane, so you're always going to make sure it's in slope-intercept form, which I hope we know by now, but friendly reminder is y equals mx plus b. Now, this is going to be an inequality, so instead of an equal sign, it's going to have an inequality. So greater than, less than, or whatever else, okay? Another thing that we have to know is if it is greater than or less than, it's going to be a dashed line. If it's got that equal sign under there, it's going to be a solid line. So it's still kind of the same thing with one variable inequalities, right? Like, so if it had the equal sign under there, it was a filled in dot or circle. Well, it's a solid line for linear inequalities. Okay, so let's do a couple examples. Y is less than or equal to negative 5x plus 2. Go on over here. Draw your coordinate plane. All right. So the first thing we check is if it is in y equals mx plus b, and sure enough, it is. So the first thing I plot is my b, which is a positive 2, so I go to the y-axis, place my dot there. And then here is my slope. So my slope is equal to negative 1 over 5. So I go down 1, and I go to the right 5. 3, 4, 5. Then I do the opposite. Up 1, 1, 2, 3, 4, 5, to the left 5. Okay. Now, I've got to look at the inequality. It's got that equal sign under there. So it's, sorry, my phone. It's got the equal sign under there. So I know it's a solid line. It's a solid line. Furthermore, I have to decide if there's shading. Remember, for one variable inequalities, we shaded the right or the left. Well, now we have to take a test point. So you're going to take a test point. The easiest test point to take is the origin. Now, you can only take the origin if it's not on the actual line, which, if I look here, it's not. Okay? So now I go back up to my original inequality, and I just rewrite it exactly as I see it. The reason I want to use the origin is because it's the easiest point. That's the point 0, 0. So I plug in my information. Y equals 0. X equals 0. Okay, so now I simplify. Negative 1/5 times 0 is 0. 0 plus 2 is 2. So now I look at this. Is that a true statement? Remember, the alligator wants to eat the bigger number. So is 0 less than or equal to 2? Yes, that is true. So since it's true, I want to shade the area. I want to shade the area that the origin is in. So I would grab my highlighter and I would shade everything starting at my line, everything below. There we go. That is my graph to the linear inequality. Here's the next one. Y is less than negative 3/4 x minus 2. Okay, draw your coordinate grid real quick. All right. Is it in y equals mx plus b? Yep. So I plot my negative 2. I go to the y-axis to a negative 2. Then I do my slope. My slope is equal to negative 3 over 4. So I go down 3, 1, 2, 3, to the right 4, 1, 2, 3, 4, and the opposite, 1, 2, 3, 1, 2, 3, 4. Now I have to look at my inequality. That is just greater than. So it's going to be a dashed line. I know that's not perfectly straight, but it is what it is. So it's going to be a dashed line. Now, I take my test point, 0, 0, right? So now I'm going to test it. This time, 0, 0 is above the line, right? So let's go ahead and see. So I rewrite it exactly as I see it. Oops, x minus 2. Now I can plug in because the test point is 0, 0. Okay. Negative 3/4 times 0 is 0. 0 is greater than negative 2. Is that a true statement? Yes, this is true. So since it's true, I want to shade where that, where the point is. And my point is here. So I need a shade above the line. Okay. Now here's the question. They could also ask you things like this. They could ask you, I guess this would be example 3. Is 4, 6 a solution? What you would do is you would look at the graph and you would go over to 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. The point is there and it is in the shaded area. So yes, that is a solution. They could ask you, is negative 2, negative 8 a solution? So you'd go to negative 2 down to negative 8. That is not in the shaded area. So no. Where it gets a little sneaky is if it's a solid line, it counts. If it's a dotted line, it doesn't. So for instance, let's take this point, 0, negative 2. That is on the line, right? This point right here. It's on the line, but that's a dashed line. So that would not be a solution. If it was a solid line, it would be, but since it's a dashed line, it is not. So it gets a little tricky there. Let's do a couple more. Example 5. 3x plus y is less than negative 2. All right, so I see if it's in y equals mx plus b. It is not, so I need to subtract my 3x over. Y is less than negative 3x minus 2. All right, now it is in y equals mx plus b. All right, good enough. Okay, so I go to negative 2 because that's my b, my y-intercept. My slope is negative 3 over 1, so I drop 3, go to the right one, and then I do the opposite, 1, 2, 3 over 1. Okay, now I look at the inequality. It does not have the equal sign under there, so it's going to be a dashed line, right? And now I need to take my test point, 0, 0. So I'm going to test 0, 0. Okay, so I start with my original. And now I plug in. So 3 times 0 plus 0. 3 times 0 is 0. 0 plus 0 is 0. So now once again, I ask myself, is this a true statement? No, that is not true. So if it's not true, obviously the point 0, 0 is not a solution within that graph. So I have to go the opposite way with my shading. So I would go below the line so that the origin is not included in that solution. If I would have gone above, remember that origin would be in there, and we know for a fact it's not a solution. So no. So I go the opposite way. Okay? Let's do maybe one more. I don't even know what we're on. 6 maybe, 7, I don't know. Let's do 4x minus y is less than or equal to 1. Okay. So I start by putting it in slope-intercept form. So I subtract my 4x over. That's negative 4x plus 1. And then I have to divide by negative 1. When I divide or multiply by a negative, I flip the inequality. And this is 4x minus 1. Okay. Okay. So my slope, or my y-intercept is negative 1. My slope is 4 over 1. So I go up 4, 1, 2, 3, 4 over 1. And down 4, 1, 2, 3, 4 over 1. It's got that equal sign on there, so it's going to be a solid line. And now I need to take my test point, 0, 0, which is right there. So I'm going to test 0, 0. So I start with my original inequality, and I plug in 0, 0. So that's 4 times 0 is 0. 0 minus 0 is 0. This is true. So since it's true, I want that point shaded. So that point is right there. So when I grab my highlighter, I want to make sure that that point is highlighted. Good? All right, one more, just in case. Y is greater than, let's just put x. Y is greater than x. So I asked myself, is that in y equals mx plus b? And the answer is yes. And if you need to, remember, if it makes you uncomfortable, just go ahead and put that plus 0, and then you can put the 1 there. Okay, so my y-intercept is 0, and then my slope is 1. So I go, it's 1 over 1, up 1 over 1, down 1, left 1. I check my inequality. So this is going to be a dashed line. And then now I've got to use my test point, but I obviously can't use the test point 0, 0 because that's on the line. I know it's included. So you can use any point that your heart desires. I'm going to use this point because it just seems good to me. So negative 1, 1. I rewrite my original. I plug in my numbers. The y is 1. My x is negative 1. That is true. So I want that to be shaded. So my point was here, so I want to shade that area. Okay, remember, if it's false, though, you have to go the opposite way. All right, here are your practice problems. I want you to graph every single one. So y is less than or equal to negative 3x plus 4. 2, y is greater than or equal to negative 7/4 x plus 4. 3, y is greater than negative 2x plus 4. What's up with all these plus 4s? Maybe not. Let's do minus 3. 4, x plus y is less than 6. And 5, 2x minus y is greater than or equal to 4. All right, there are your practice problems.